In this video, we're going to provide detailed examples of how to select parts and regions of a mesh using several different methods. You will need to select parts and regions in order to position your mesh before projecting it to a surface. For example, to move a node, attach an edge to a spline curve, or project a face to a cylinder wall, you will first need to select the part. It's critical to become proficient at the selection process and to know all of the different methods. Some methods will be better suited for certain situations. It's also important to understand the notation syntax for parts and regions so that you better understand them when you see them in your commands. The four main ways to select parts are using your mouse on the computational picture, using the index bars in the computational window, using the mouse in the physical window, and using the selection function keys. This lesson provides many examples and may be more than you wish to watch as a beginner. You could instead watch the screen navigation TrueGrid quick tutorial on our YouTube channel. Then come back to this longer video once you're ready to master TrueGrid. We are going to start this lesson with the multi-block mesh that we built in the video named Indices and Coordinates. You can also find the block command in your training manual on the page titled Physical Window Showing Indices and Coordinates. Now Dr. Rainsberger is going to start here by copying the block command right out of the training manual and into his dialog box.
And I use the middle mouse button to fill in the numbers. By the way, you don't need to put down the periods the way they are shown here.
In TrueGrid, everything is a floating point number. So when it needs an integer, it finds the closest integer to the floating point number.
Our main interest is going to be this window here. The rotation, move, zoom, and frame work both in the physical and the computational. I'm going to rotate this. Click and drag with the middle mouse button. And right now my graphics is in wireframe. I want it in hide. So I'm going to click on hide.
We are going to focus on these little half disks that we find on the computational index sidebars.
This is the I index bar. And when you move the mouse close to one of the nodes, it highlights automatically with white. And if you move it over to the next, it moves to the next partition. And that partition is obvious here because every face is a partition in the mesh.
Notice that in the physical window, you can see that there are 5 elements between partition 1 and 2. This comes from our block command.
Now, there are various ways that we can select portions of the mesh. We might want to select a block and delete it.
Notice the newly exposed faces are magenta to show you where the block was deleted. You can use the undo tool to return the mesh to its original form.
We might want to select a face and project it to a surface. We might want to select an edge and attach it to a 3D curve. Or we may want to select a vertex so that we can move it. Those are just some examples of why we would want to make these kinds of selections. Notice that when I move the mouse close to a vertex, that would be one of the corners of our blocks. I mean, if I do this, you can see it's a block of numerous elements. And if I click here, I'm selecting a vertex of that block. They're in red. Now we can also select an edge. And the way you do that is you move the mouse close to one of the vertices of the edge and do a click and hold the mouse button down. You drag the mouse over to the other end of the edge that you want to select. And yes, you can select the composite edge. And when you select an edge, it's colored blue. Well, let's look at what happens to the index bars when we make these selections. So for example, when I click here and get a vertex, what happens? Well, here's a node on the I index bar that's red. And there's a node in the J index bar that's red. And in the K index bar, we have a node that's red. That's what happens when we select a vertex.
If you select a part or a region of a mesh, you can use F1 to copy the region's notation into a command line or dialog box. Let's examine the syntax of a vertex notation. Each region notation is made up of 6 numbers. For a vertex, the first and the fourth will always be the same, the second and the fifth will always be the same, and the third and the sixth will always be the same. These pairs correspond to the reduced indice nodes on the index bars that are red, but this is not the case for all regions, just for vertices. This notation is telling us that we have selected the third node in the I direction, the third node in the J direction, and the first node in the K direction. Let's look at one more example.
We can guess at what's going to be written here. 5, 3, 2, and then it's repeated. 5, 3, 2. Let's try it out. F1. There it is. 5, 3, 2, 5, 3, 2. When I select an edge, and then I use the F1 key for the notation, I get 2, 2, 2, 3, 2, 2. You'll notice that we have an interval selected in the I index bar from 2 to 3. But then we have the 2 nodes selected in both the J and the K. And that's what this means. It means I goes from 2 to 3, J goes from 2 to 2, so it's a constant, and K goes from 2 to 2. It's a constant. And this is the notation for an edge. The pattern is one of the 3 directions in the index bars has an interval selected between the nodes. You can see it with a red line right here. In this case, between 2 and 3 in the I direction. And then a constant node for the J and the K. In other words, only a single node is selected in the J and in the K. Now that is referred to as an I edge. It's the bar that has an interval selected that gives it its type. So in this case, we have the interval selected from 2 to 3 in the I direction. So this is an I edge. Now I could have selected this edge right here instead. So now I've got a node selected in the I direction instead of the interval between 2 and 3. But I have an interval selected in the J direction from 1 to 2 that corresponds to this interval that forms the edge. And in the K direction, we have a single node selected. So this type of edge is known as a J edge because the interval that defines the edge, the direction of the edge, is in the J direction. Now suppose we want to select a face from one vertex to an opposite diagonal vertex. That's a click and drag operation. Now what you'll notice in this case is that 2 of our index bars have an interval selected. In the I direction, I chose from 2 to 4, but it's the interval. No nodes have been highlighted. Now in the J direction, I also have an interval selected, and in the K direction, there's a single node selected. Now this kind of face is referred to as a K-face occurrence. It's the one that without an interval being selected. If I select this face, we have the same basic pattern. We have an interval in I and an interval in K, but a node is selected in the J direction. So this is known as a J face. And finally, we can select solids. For instance, we could do a click and drag from here to here, click and drag from one corner of a region to the opposite diagonal corner, and you'll select a solid. Now you'll notice that in the case of a solid, we have an interval selected in the I direction, an interval selected in the J, and an interval selected in the K. Now, one more thing about this aspect of the computational window. Notice that right now I've selected a solid. Now I can hit F2 to clear away that selection so I can start a new selection, such as a vertex.
Now that you have learned the notation for a vertex, an edge, a face, and a solid, you will note that the 6 positions in the notation each have a purpose. The first position is I minimum, and the second is J minimum, and then K minimum. We then move to I maximum, J maximum, K maximum, and they are all paired off into directional sets of 2. When both numbers in a set match, that indicates a constant or that a node is selected on the corresponding index bar. When the numbers in a set do not match, it means that there is a range and one or more segments have been selected in the corresponding index bar.
So suppose I have that vertex and I say, now I want this one as well. This is in the K direction. So I've got a maximum K index. In fact, we can go up here and say, oh yeah, right there's the red node. This will be the minimum K. Now, if I want that one as well, I come up here to the index bar and click on the first K. And now I've got 2 of them. Now, when you do vertices, you can't do other kinds of things. You can't do an edge, you can't do a face, you can't do a solid. All vertices or none. Now, suppose you wanted to choose this vertex as well. Now, this is in the I direction, so I'll click on this. And sure enough, but there's an added consequence. I get that one too. So basically what you're getting is a set operation. It's saying the i's at 1 and the i's at 3, where j is 3 and k is either 1 or 2. If you wanted these 2 and this one, you'd have to have one command that used this pair and the second command that used just this one. But most of the time, when we make these 2 selections and this one, we also mean to do this one. So suppose I select this edge right here, and then I say, well, I want this edge as well. Well, this is in the I direction, and it's the maximum edge, maximum I interval from 4 to 5. So what I do is I do a click and drag to make the selection, the interval between 4 and 5. Suppose I want not only these 2 edges, but these 2 as well. I just click on K. Notice that I'm able to select nodes multiple times in the K direction, and I suppose we could do it in the J direction as well. But I can only select intervals in the 3rd direction, in this case in the I direction. So the point is that this is known as an I edge because we have intervals in the I direction. If I'm taking and selecting multiple edges, they have to be all of the same type. I cannot have an I edge and a J edge in the same instance. How do we use this? Because we've talked about commands that have regions, and it's the minimum and maximum of the 3 directions. Well, how do we do 2 intervals or 2 selections along nodes? We can't. So that's why we have a second type of command with a second type of notation, which is more powerful but more complicated. It's always the trade-off. So I'm going to show you what that notation looks like. But to do that, I have to change my generic command from CMD to CMDI. This is known as an index progression. When I hit F1, because I have the I at the end of this command, it interpreted this command as an index progression command, which allows for more complicated objects like this. Now, this is known as an index progression. It has 3 lists of numbers, the I list, the J list, and the K list. What it's doing is mimicking what you see down here. In the case of the I list, we have an interval from 2 to 3 and from 4 to 5. Turn the and into a 0. And we look at the I list for an index progression. It's 2 to 3 and 4 to 5. What about the J? Well, this is where the minus signs come in. In an index progression, when you have a node selected along an index bar, it's that node's number with a minus sign. So here we have a -2 and a -3. Well, let's look at what's up here. A -2 and a -3. So that's how the J index list is formed. Now let's look at the K. We've got a node selected at K1 and at K2. Sure enough, a -1 and a -2. And so this approach gives us much greater flexibility in selecting multiple objects. Well, let's go to shells now. I select a face. Now that can be identified as a region, but it also can be identified as a index progression. So I hit F1 and it prints into the list 1 to 2 in the I direction, 2 to 3 in the J, and a -2 in the K. Well, sure enough, we have an interval selected in the I from 1 to 2, an interval selected in the J from 2 to 3, and a node selected in the K. But now suppose I want to select this face as well. So I come down here to the index bar and do a click and drag from 4 to 5. And I've got this one that's selected as well. So now let's see what we get here when I hit the F1 key. Sure enough, in the I direction, 1 to 2 and 4 to 5. 1 to 2 and 4 to 5. And in the J direction from 1 to 2, sure enough, 1 to 2. And in the K direction, a node at 2, so that's a -2. Suppose I want to select all of these outer faces, all in one. What we do is select the solid region from one vertex to the opposite diagonal vertex. So we've selected the entire block or the entire region. And then I go back and I select the faces of that, the outer faces of that object. So for example, in the I direction, suppose I want this face. Well, that's the first I face. So I leave everything the way it is here, and I add to it a click of a node so that it turns it red. Now suppose I also want the face over here. So I'll click on this node. So now I have two opposite faces. And now in the J direction, I want to do the same. I select the first node. That gets me this set of faces. And this one. So I now have the outer faces that go around. And let's look at what it looks like with the F1 key. So here we have a -1 and a -5, but there's no 0 between them. Remember, there were zeros between them before, and I would use the word and. When I do this description, I say from a -1 to a -5. There's no and in there. There's no 0. And that's what we have here. We have it -1 to a -5, and the nodes at 1 and 5 have been selected. So that's why they're minus. And the similar thing on the J index bar. It's a -1 to -3, a -1 to a -3. Now, this may not be the only pattern that we would use to select faces. For example, we might also select the bottom K face by clicking here. So now that's selected as well. And I might turn off this face right here. So I'll turn it off. This technique allows us a wide range of patterns of things we can select or not select. And this principle of select the solid first and then go back and click on the nodes of the faces that you want to use. Now the same thing is true with solids. I'll start with selecting a solid, and you'll notice that in the I direction, from 1 to 2. And I can then come back here and also select from 3 to 4. And once again, we can use the F1 key to see what this notation produces. And so we have from 1 to 2 and from 3 to 4. That's in the I direction. In the J direction from 1 to 2, and in the K direction from 1 to 2, and that produced these two selections. You'll notice that the I index bar, for example, has a white line above it, and at the corner there's a miter. And the best way to describe this is to say that everything that is in that polygon formed by the white line on the miter and above, and then the frame around the computational window, that space, that area belongs to the index bar. And I'll hit the F2 key to clear out my selection to make my point. What happens is that when you put the mouse into this region, it's going to fall within the sphere of influence of the closest node. So as you see, I put my mouse to the very left of the I index, and I move it in, and it highlights the first face, the first partition in the I direction. So this is all the closer I have to get to select that node, because if I click now, I select that face. That node is now red. And by the way, you can unselect doing the exact same thing, so it toggles back and forth. Now, as I move the mouse closer towards 2, at some point, 2 becomes the owner of the space around it. Right there is where it changed. And now I'm in the sphere of influence of number 2. And move it further. Now I'm in 3. Now I'm in 4 and 5. Now the reason I'm telling you this is so that you do not try to be perfect at this. There's plenty of room here for you to get sloppy, and that's the way to do it. Now there's another approach to selecting objects in the computational window. If you recall, the F5 function key and the F6 function key can be used to select objects. So you could move the mouse close to a vertex like this and hit F5, and then move the mouse to another vertex and hit F6. Now that does not seem very useful because I can do it faster just by doing this. But this feature works in the physical window. So instead of selecting that face in this fashion, I could come over here to the physical picture, move the mouse close to the vertex of the region I want to select and hit F5. That's the same as doing a click in the computational window. So I move my mouse close to the vertex and hit F5. And now to get a face, for example, I move the mouse to the opposite diagonal vertex of that face and hit F6. Now you can get vertices, you can get edges, faces, or solids the same way. So basically the F5 and F6 function keys work like click, that's the F5, and drag to some other corner, that's the F6. So the click and drag and the F5, F6 work the same. And then there's one other way. If we go back to the environment window and we go to the pick panel, click on the word pick and select region. Now the left mouse button works on the physical window the same as it does on the computational. So for example, if I wanted to select that region with the left mouse button, I do this. We get the same regions. And each one of these methods I've shown you have its place.